on task 1 in lab 9, at least. If you can get through that far today, whatever time that happens to be, call it quits for the day, and we can finish up the remainder of it tomorrow morning. Okay? So that is what today looks like. So, SD-WAN templates and policies. It's huge, 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 you guys. It's it's how we make the devices function the way that we want them to function in our production environment. Now, templates. There's two different ways that we can create templates in our production environment. We can create the templates that are device templates based upon feature templates, and we can also configure an CLI template as well. Now, I want you to, in the lab exercise, walk through both of those techniques. You may have some routers in your production network that were attached to device templates created from feature templates, and you may choose to have some routers created using CLI-based device templates instead. Two different things. Now, I don't want to confuse you guys before I start flipping slides. A CLI, a device template that is created using a CLI template is not the same thing as CLI mode. Okay? Now, a CLI mode, if we refresh our memories on what that means, a router can be in one of two modes of operation, and it has to be in one of two. If the device happens to be in CLI mode, it means that you can log locally into the router and you can make changes and you can commit them. That's if it's in CLI mode. If it's in vManage mode, it means that the management now has to come from vManage, and furthermore, it also means that that device is attached to a device template. Okay? So if it's in vManage mode, it's attached to a device template, and you cannot make local changes on the router via configuration mode. If it's in CLI mode, you can. So that's the difference between vManage and CLI mode. Now, as far as templates are concerned, that we have device templates created using feature templates, and we also have a CLI template that can be used as well. And you don't have to have every router configured exactly the same way. You can use device templates from feature templates on some routers, and you may choose to use CLI-based templates on other routers. And you will have to make a decision in your own production network which you prefer. There isn't a best practice of one or the other, but you just may find that, hey, CLI-based templates makes more sense to me as opposed to using a device template created from feature templates. If you have CLI templates, you're going to have more knowledge of command line syntax, though. I will tell you that. And using feature templates, you don't. You just fill in the blanks, fill in the parameters, and attach a device then to that device template. So it should be obvious why templates are so beneficial for you in production network. So the benefits, first and foremost, control deployment. So a device is not going to be completely functional in your production network until it is completely configured, of course. Well, the way we completely configure it is by attaching a device template to that device. Or you've logged into the router locally via the CLI and you put in all of the configuration, one or the other. But by using a template, it's as Cisco says, it's a single source of truth. Because you can configure a template and let 50 routers be attached to that template if you want to. So, and for me personally, that's wonderful. And the reason is because I hate to type. Not that I hate to type, but I'm a clumsy typist. The more that I have to type, the more likely I'm going to have errors as a result of my inability to type very well. So by creating one template and then using that template over and over and over and over again just makes more sense. So that's why they call it a single source of truth. And built in a scalability, right? You don't need to know the command syntax to make your routers function. It's all going to be based upon parameters that you define in those device templates. Now, it's used Not necessarily used in ZTP, but it's used in conjunction with ZTP. Again, you buy a brand new router and you have it drop shipped to a branch location. Nobody touches the router until it gets to the remote location. The installer there unboxes the router, plugs in the power cables, plugs in the network cables, turns it on. Now, if there's a device template created for that device in vManage already, which would be done beforehand, and you attached that device to that device template beforehand in vManage, then when that router boots up, remember the first thing it's going to do is call home to vBond. When it calls home to vBond, vBond says, here are a list of your vSmart controllers, and here's a list of your vManage controllers. Then the router sets up a DTLS connection to vManage and vBond. Across that DTLS connection to vManage, here comes your configuration, your full-blown configuration based upon the device template that vManage has attached that router to. So you see it's used in conjunction with ZTP or plug and play for that matter. So this is going to be absolutely enormous, you guys, designing the templates. You know, just like I know a lot of you guys come from a routing and switching background. I know that. And so because of that, you also probably have a pretty comfortable background with access control lists, right? We all have worked with access control lists in the past in classical and typical routers. Now, I know I can't do this. I don't have the brain cells. I don't have the horsepower between my ears to do what I'm about to say. There is no way I can sit down on a keyboard and say, today is the day for ACLs. And boom, 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 start typing away. There's just no way I can do that without first having a plan in place. Everything about these templates is going to be based upon how completely and accurately you plan for it. Then you're going to design those templates. So, you know, same thing is going to, so the issue about access control list also applies here as well. You're going to have to get a team of your people together if this isn't rolled out already and come up with how many different templates are you going to need for the number of routers that you have. Most of the time, and this isn't inclusive or exclusive, but most of the time you configure a device template per model router. So right off the bat, if you have 5 different model routers, you could end up with 5 different device templates for 5 different model routers. Plus, if you don't implement feature consistency within a given model router, then you could actually end up with multiple device templates for the same model router. So at the end of the day, you know, plan based upon your design. You know, you're going to have design for campus-based routers that's going to be different for data center-based routers. That's different from branch or home office type of routers. So it's the design that you create for those. So plan. Now, the lab exercise, though, we have done this part for you. The planning part, we've already done. We're going to say, here's all of the feature templates we want you to create. Here's what we want you to call them by name. Here's all the parameters we want you to define in each one of those. And then when you define a device template, use those features, and then you attach a router to that device template. So we would have done all the hard work for you. All you've got to do is define the parameters for the feature templates and define your device template and then attach your branch VEdge1 router to that. So all the planning we've done. Now I cannot emphasize this enough. As you're going through the lab though for your templates and even more importantly on your policies, pay attention to detail. Absolutely do not skip paragraphs in the lab guide. You'll be going back and redoing them if you do. So pay attention to detail as you go through the lab. So as I indicated, create a template and associate it to as many devices as you can. So that's going to be this automated. So, Ron, can I get your mute, please? Frank, I think that's.
I have a question.
Yeah.
That's why I unmuted.
Okay.
Could you real quick explain the difference between a CLI template and a other template? I think you
Okay,
said that early at the very beginning.
that's actually coming as part of the material. I'm just letting you
All
know
right, no worries.
that there are two different ways that templates can be created. Device templates can be created in two different ways. And how you configure each one of those, that's part of the content. So I will
Okay.
walk you through that. Okay, so step number 0 of 547 is to plan your device template. So these are the things you've got to know ahead of time before you decide to sit down and start typing away and defining your template. So you got to be able to identify your devices. Now, if you've got a brand new router, it's not going to be identified by its name because that's not going to exist yet. Remember, you're shipping a router from Cisco over to the branch location. It has a default name of vEdge. So identify the device by its chassis number. So you're going to have to know each router by its chassis number, that long value that we put in earlier in the labs yesterday. Identify how many interfaces are going to be active on that router. And again, that could be different between branch routers as opposed to data center routers. But if you've got a router and that router is connecting to a gold transport and that router is connecting to a silver transport and you've got a site local network, well, this might be gig ethernet 0/1. This could be gig ethernet 0/2. This might be gig ethernet 0/0 for all we know. And on top of that, you have a system IP address that you've got to be cognizant of. You probably will be configuring loopback interfaces if you are running things like BGP and OSPF, right? So planning how many interfaces you have. Now, and not so much knowing how many interfaces you have, but consistency. If you configure a router so that gig ethernet 0/1 always connects to the gold transport and gig ethernet 0/2 always connects to the silver transport, that's one device template. But if you have other routers where gig ethernet 0/2 connects to the gold and gig ethernet 0/1 connects to silver, that'll be a different device template. So as long as you maintain feature consistency, that's going to allow you to use the same template more than you would otherwise. So what are your transport connections? So this router connects to gold and silver. Now the gold might be MPLS, the silver might be business internet. But what if you've got a more of a global type of a presence and you've got internet or network connections in Asia that don't exist in the US? More and more transport connections you're going to have, so those have to be planned out. And like I said before, every one of these interfaces that exist on your router, you're going to have an IP addressing scheme determined ahead of time that's going to be applied to all those devices. Every router has to have, in addition to a system IP, it has to have a site ID as well, a number between 1 and 4 billion. I think I mentioned that already. But that's, the fact that every router's geographic location has to have a unique numeric site ID, that's the only requirement. Make them all different. But site IDs are used when you create policies later on. So you're going to say, I want to change the default behavior of some collection of routers, and you're going to define that by site IDs. So if you have a site ID range of, say, 100 through 200, and that applies to Western region routers, then you can apply a policy to the site list that's identifying site IDs 100 and 200, and that policy only affects Western region routers and not Eastern region routers. So site IDs, again, it's in this list of plan because that's something you need to determine in advance. But it is any number between 1 and 4 billion. And every router also has host names. So this is not a bad page to sit down with your team and go, this is what we need to identify ahead of time. And I will also add a number 8 here as well, and that's going to be topology, if I were to do it myself. So have more of an idea of what your topology of your network is going to be in, And this could actually be on a per VPN basis, especially if you're doing application aware routing. And this is going to come hand in hand when you start setting up your policies. And that's why templates and policies are covered together in the same module, because you can do templates without policies, but some policies require templates to be created, and you associate a policy to a device template. Okay, so you log into vManage. You log into vManage, and you go to configuration and then templates, as is indicated here on the right-hand side. So you'll go into configuration and then templates. When you go into configuration and templates, you have a choice between device templates and feature templates, also shown here as well. So if you're going to create a device template for a model router, a 4351 model router, or a B-Edge 1000 model router, when you click on device, you've got an option here. That option is, are you going to create a device template from feature templates, or are you going to configure a device template as a CLI template? And I'm going to walk you through and show you the configuration in both ways. Now, hopefully it goes without saying, if I'm going to create a device template from feature templates, then guess what? The features have to already exist. You can't create a device template from feature templates if you have no feature templates. So this gives you a collection of feature templates here. So this just shows you 9 of them. Actually, there's about 25. There were 25 feature templates the last time I looked, and I haven't logged into vManage and looked at these templates yet in version 19.2. There may be more, but there's 25 different categories of feature templates. Kind of take a look at these. AAA. So AAA is a feature. Banner, archive is a feature. BFD. Even though BFD is enabled by default, if you want to alter those default timers, the poll interval, hello interval, the multipliers, you would add a BFD feature template and change those default parameters within the feature template. You've also got BGP. In addition, you've also got OSPF as well, not shown here. Bridging, you've got the ability to set up your router as a DHCP server, multicast capabilities, syslog. You've also got SNMP listed is here. You've also got OMP that can be customized as a feature template, and the list kind of goes on and on. In addition to VPN interfaces, which will be used a lot. So if you've got 25 different categories of feature templates, if you've got 25 different feature templates that you can choose from, let me give you a number. The last folks that I had a class with, like I said, they were from the Department of Defense, but they had 87 feature templates. Now kind of think about that for a second. If they had 87 feature templates, but there are only 25 to choose from, then what's obvious, right? Some device template or some feature templates are used more than once. And that's absolutely true. Here's an example. You've got a Western region implementation and you've got an Eastern region implementation. Western region has AAA servers, and Eastern region also has AAA servers, and they're different. So you might add the AAA feature template twice. Once for Western region and a different one for Eastern region. What about SNMP? You might have SNMP servers in Western region where the read, write, and read-only community streams are different than the ones in the Eastern region. So you might add SNMP twice. And then all of your interfaces, your VPN interfaces need to be added. So if I've got a router that is connecting to the gold transport and to the silver transport, that's a VPN interface and that's a VPN interface. So you add that twice. You've got VPNs themselves. I've got VPN 0 that needs to be configured. And back here, I might have VPN 1, VPN 2, VPN 4, VPN 7. I will add those 4 times. So you see, it won't take long before these 25 combinations of features, you'll end up with about 87 yourself. Now, just because they're configured, you added 87 different feature templates. If you were to stop there, you've really not accomplished a whole lot, other than a lot of typing. You've created all of the feature templates, but they're not being used anywhere. So the next step would be to take those feature templates and associate them to a device template. So if your goal is to create a device template based upon feature templates, you first have to go here, which is indicated down there, and the first thing you got to decide upon is these feature templates, a feature template that I'm about to create, from this list of 25, what model router is it going to be associated with? Now you can hold down the control key and you can select multiple routers. But be careful there, because if you select multiple routers and you add a feature template like cellular, for example, and that is a feature supported on some of those routers, but not every model router, then that's going to fail now when you try to apply this to the routers. So when you're trying to do feature consistency, just make sure that the routers that you choose here, if you're going to choose more than one router, they all support the feature that you're going to be implementing. Now, granted, things like AAA and BFD and maybe the routing protocols, banners, they would all support that. When you start getting into things like cellular and VPN interfaces and things like that, that's going to be different per router, because a low-end router may only provide you with one or two network connections, and the higher-end routers could be much more than that. So how many interfaces are you going to configure? So this is back to that one very important word that I mentioned earlier, plan. You've got to know what feature richness you're trying to deploy. Now, when you get into the lab, you're going to be able to see all of these features. And if you're planning this in your production network, sit down with your staff and say, each feature, are we going to use IGMP in our production network? If not, then that's one less of the 25. Are we going to be setting up SNMP? Are we going to be creating our banners? And if so, well, how many different banners do we want to choose from? That's how many of the same feature template you would be creating. So feature templates, the first lab exercise is going to have you go to device templates created from feature templates. And then a later lab will have you create your CLI templates. Now, the CLI template, in essence, if you look at it, it looks as though you did a show run on a router. That's what it looks like. So you have to create it based upon proper command line syntax. But the feature templates, your device templates created from feature templates, you just decide which features and how many of each feature it is that you want to deploy.
Hey, Roger, I got a quick question. It
Sure.
may be off topic, but can you speak about the integration to DNA Center at all with SD-WAN, with maybe templates or?
I cannot. I don't know enough about DNA Center to talk with it. I know that there's the integration to DNA Center, but honestly, I couldn't talk on that path. Only because I haven't had training on DNA Center myself. So unfortunately, that's a no. It is something that I need to get, and eventually I will. But right now, I don't have DNA Center under my belt. I think possibly, and Jeff is kind of getting up to speed on SD-WAN. But Jeff, are you knowledgeable in DNA Center? So unfortunately, the answer to that question is probably no. But, and with your integration to DNA Center, I'm going to assume that your deployment is probably going to be a managed service, right? Would that be a correct assumption on my part?
That's actually a good question. I came into the company after they purchased the solution, so
Uh-huh.
I need to reach out and ask that question. I think it's going to be in-house.
Okay. Well, if it is going to be in-house, that's absolutely something then that you're going to have other members of your team though that are, you're going to pull strengths from other members that use their strengths to your advantage. So, if nobody on your team is knowledgeable in DNA Center, and that's going to be your implementation, I foresee training in your future, right? So,
Yeah, I just didn't know if the topic goes into maybe in the future if they redesign this class, the integration with the vManage and the templates can be, integrated into DNA Center because that's one of the features of DNA Center is templates.
well, no. This is specifically vManage, and I know vManage could be integrated into DNA Center, but still, you're doing this from vManage, not DNA Center. Follow
Right.
me?
Yes.
So, so the look and the feel would be still very similar, if not identical, regardless whether this is deployed in a DNA center or not. Because it's vManaged, it's managing your devices, and vManage itself, instead of being in a virtualized environment, is part of your DNA center implementation. But what vManage does is the same, regardless of how it's deployed. Okay, so
Thanks.
your configuration elements for these templates. First and foremost, something that you've already seen are this system block of parameters. So the system block of parameters, system IP, site ID, org, and VBON. Those already exist, but guess what? This is also where you would add those optional features. Guess what? SNMP is an optional feature. OMP, TACACS, logging, AAA, GPS, security. So if you were defining that, that could end up being 1, 2, 3, 4, 5, 6, 7, 8 additional feature templates alone that you might be deploying on your routers. Again, it really depends what degree of feature richness you're looking for. In addition to system, there is also a transport VPN. That is, and it must be VPN 0. You define which physical interfaces on that router are going to participate in VPN 0. So again, back to that router, this is going to the gold transport. This is going to the silver transport. Well, all of that is SD-WAN, right? So I'm communicating using VPN 0 here. This interface, gig Ethernet 0/1, this interface, gig Ethernet 0/2, are going to participate in VPN 0. And then you also have a management VPN. That is going to be, first off, an out-of-band management, but that's VPN 512. Which interface on your router is going to participate in VPN 512 as well? On the back side of the router, you have service VPNs. Now, this is more appropriately referred to as site local, but they call it service VPNs here. That's going to be in the range of 1 through 511. So if you configure VPN 1, 2, 5, and 6, then you've got 4 VPNs that need to be added to this router. Each VPN is a different feature. So that'll be added 4 times or 5 times, whatever it's going to be. And you define which interfaces a given VPN is going to be associated to. Now, with regard to interfaces, maybe this interface here, gig Ethernet 0/0, is going to be used for the service side VPN. I don't want to get into this debate here just yet, but we come up with an issue a few weeks back where I've got multiple VPNs that I want to associate to a physical interface. Well, problem is when you configure VPN 1, you associate what interface that's going to be used for. When you configure VPN 2, you're going to associate that to a different interface. But wait a minute, I've only got one interface on the router that I can use. So what you can do is you can say that interface back here that's actually going to be connecting to sub-interfaces. So this could be gig Ethernet 0/0, but I can say 0/0.1, 0/0.2, 0/0.3, have different IP addresses for each one of those. And then this can be VPN1, this could be VPN2, and that could be VPN3 if you needed to do something like that. Now, the only requirement is you must associate the physical interface. These are the sub-interfaces. You must associate the physical interface to VPN0. It's a requirement. So that's if you don't want to have physical interfaces on the router on the site local side. So those are ways to get around the issue. You could also configure secondary addresses on the interfaces as well. That's also supported. And then finally, your policy, any policies, and that's going to be coming up in the latter half of the module. So all of that collectively is a device template. So you basically just say, hey, this is everything that I'm going to configure for a device template. Is there any combinations of these features that I want to roll out that needs to be different? If the answer is yes, then it's another device template. Really straightforward in that regard. Now, in comparison to some things that maybe some of you may already know, if you guys, any of you guys come from a voice over IP environment and you're working with Call Manager, we have something similar in Call Manager, and that's called a device pool, right? So if you configure a device pool, you can define all of those variables in the device pool and let that device pool be used by as many routers that uses the same feature consistency. So if you say, you know what, all of these phones, not routed, all of these phones uses this feature richness in a device pool. Are there any features in a device pool not included in that? And if the answer is yes, then you have to create a new device pool. Same kind of thing here. So that is your configuration elements within a device. So as you're configuring all of these feature templates, now the configuration page of a feature template will vary depending upon what feature that happens to be. OSPF, for example, you've got your areas and you've got your the different types of LSAs that are being used, the type of router that's actually configured, whether it's an area border router or an internal router. On the other hand, if you're configuring a BFD feature template, then the parameters will be what your poll interval is and your hello intervals and that kind of thing. So the configuration page will vary depending upon what the template is defined for. But every single one of those features by default are defined as default. Now, if you configure a new device, excuse me, if you define a new feature template and every single parameter in that feature template is set to default and you leave it that way, then why bother with it? Especially if it's being offered as a system provided feature for you in the first place. Like, for example, OMP. Like, for example, BFD. Both of those are feature templates, but those are on and enabled by default. So unless you're going to customize OMP, unless you're going to customize BFD, there's no reason to add an OMP or a BFD template. It's already there provided for you, and use it as the default provided value for the system. Now, every single parameter in a feature template is going to be one of three choices. If you have a default value, that's the system provided default. If it says default like it does here, that's grayed out. You can't even type in anything in there if you wanted to. That's what default means. I want to use this default value and I don't want to change it. But what if that default value is something that you don't want to use? Now you can change that one parameter to either, and this is a drop-down option, to either global or device specific. Now, here's where you have to know your environment. If I want to change this default value, but I want it to be something different that every device using this template is going to use, then you would change that to global. So this applies to all devices that's using this feature template. But then you define what that new value is. So in essence, if you change the parameter from default to global, and then you define what that global parameter happens to be, that becomes the new default, okay? And the last one is device specific, and that should go without saying, right? If it's a parameter that has to be unique per device, you cannot leave it to default. You cannot set it to global. It must be set to device specific. For example, IPv4 addresses. So as you're setting up these IPv4 addresses, you're going to change it from default to device specific. Now the parameter looks like, or the icon looks like that. You're not going to be allowed to type anything in there. Because if you type anything in here now, how many devices can use that parameter? Only one. So the device specific, you intentionally leave that blank. And then when you finish configuring all of your feature templates, associate them to a device template, the last step is to attach a router to that device template. So all device specific parameters have to be defined outside of your device template. And you'll see this once you start getting into the configuration in your app. Now this is kind of a word of caution for you here. You change it to device specific, you can either enter in a key or you can leave it to the default. If you don't enter in a key, this is what you're going to see showing up when you've got to define those device specific parameters. So imagine, and this is what your page is going to look like here. So let me just kind of go like this. Here's your page that you're configuring your device specific parameters on. So this side here is going to say IPv4 address. A little bit more than that, but that's what it'll show you. IPv4 address. IPv4 IPv4 address. And that's repeated for every one of the interfaces that you've got created. And then over here on the right hand side of that, you'll have a field that you can actually define that value. So if you're defining 1, 2, 3, 4 parameters that have IPv4 addresses, remember you've got Gig Ethernet 01, you've got Gig Ethernet 02, and Gig Ethernet 00, which will be on your site local side. This goes to the gold transport. This goes to the silver transport. This interface here has to be 1.1.7.11/24. This has to be 1.2.9.11/24. But they all prompt you with exactly the same information. Which one of these addresses go where, right? So what you can do is you can put your cursor right here and you'll get a balloon window that pops up and says, oh, this is Gigabit Ethernet 02. You put your cursor here, it'll say, oh, this is Gigabit Ethernet 01. So you'll know which interface each one of those are, but you've got to put your cursor over here in order to figure out what IP address you put in each one of those fields. Now, that's if you don't enter in a key. If you do decide to enter in a key, you can put in there Gig Ethernet IPv4 address. Gig Ethernet 00 for the first one, Gig Ethernet 01 for the second, and now this is what shows up on that left-hand side instead of it all being the same. So, and the lab will point that out to you, but again, it's up to you. If you see 5 parameters that says IPv4 interface address, and you see that 5 times, don't put the right address in the wrong field. So just make sure that, hey, just enter in a key when you're defining these device-specific parameters. And you, instead of seeing that now, then you'll see this value. It's looking specifically for an interface that you define. And you can put anything you want in here. You can just say GE00 IP to give you kind of a hint as to what it's looking for. But If you don't do that, then all interfaces that are device specific that are IPv4 addresses would look exactly like that, and you'll see that 5 times, or whatever number of interfaces you have. Okay, so we create our feature templates to begin with here. So when you create a feature template, you're going to go in vManage on configuration. You're going to choose templates. When you choose templates, you've got to give your template a reference to what model router that template is intended for. So again, you can hold down the control key if you want to, and you can select multiple routers at the same time. But just make sure that the feature that you're adding is supported on every router that you selected, or just choose one router. So once I've chosen the routers that I want to apply this new feature that I'm about to define on, then you choose from the list of 25, it looks just like that, which feature it is that you want to add. And they just happen to be showing you OMP. So you choose OMP, you have to give the device or the feature template a name, and you have to define a description for that. You cannot leave the description field blank. So what I normally do is type whatever it is for the naming convention, and I copy that and just paste it in there. And again, this tells you what model router as a result of this page that you chose. Now, this is all of the parameters for that particular feature template, which in this case is OMP. Notice that every single one of those has a checkbox. That's default values. Now, if you want to accept the default values, fine. But again, just make sure that as you define these features that you drop these menu options down. Again, here's where you can drop it down and you can choose either you can choose either default, global, or device specific. But every single parameter, every single one, you've got to take a look at and go, okay, do I want to keep the system provided default, or do I want to change that to something else that every router is going to use and make it global, or is this a parameter that has to be device specific? So certainly something that hopefully will be obvious to you is if you set up a parameter that needs to be device specific, like for example, an IP address on an interface, that must be device specific. But if you leave it to default, or if you change it to global, it's never ever going to work because that's a parameter that has to be unique on your routers. So, and it'll become, as you get deeper and deeper into the configuration of these feature templates, it'll become horribly obvious as to whether a parameter needs to be defined as device specific, global, or device default. Okay, so once I've got all 87 features defined, they're there. You can use them anywhere you want. But make sure you come up with a good naming convention for those feature templates. Remember, we had options like, for example, AAA, right? Or let's see, SNMP. So you're adding SNMP 3 times. You're adding AAA 3 times because you got 3 regions. Don't come up with the naming convention of AAA-1, AAA-2, AAA-3, right? Come up with a naming convention like Western Region AAA, Eastern Region AAA, Western Region SNMP. You know, naming convention that when you see them listed alphabetically, you'll be able to know which one should be used where, based upon a good naming convention. So, enough about that. You'll see that when we get into labs. Okay, so creating these device templates. Once we've got our 87 feature templates created, come back to configuration, templates, and choose device this time. So when you choose device, you're going to have a drop-down option here as to which model number this device template is going to be associated to, and can give your template that you're defining a name. Don't use naming conventions like this. If you've got a template by the name of branch-veg1, just that name alone kind of implies that this template is intended to be used on one router, right? Instead, make a template name something like Western Region 4351 routers or Eastern Region 4351 routers or something like that, so that, if you've got feature inconsistency between the Western region and the Eastern region routers, you've got to know which device template to attach to which router. So have naming conventions that are intuitive. Now, when you go to the device template configuration page, this is what it looks like. You got a bar that you can slide down on the right-hand side. So as you slide down from the top to the bottom here, it automatically goes from basic information, transport, to service VPNs, to additional. Or these are also clickable items. You can click on any one of those, and that'll drop down to that section of the device template. But you've got to go all the way from the top all the way to the bottom before you actually get to the save button or an update button if you're making modifications to that. Now, you're creating a brand new device template for some model router, and this is the name you've chosen. Notice that every single one of these, what you're given. You're given factory default for the system block of information, factory default template for logging, factory default AAA. So if you've chosen OMP or AAA or BF or whatever, drop the item down and the name of that feature template you just defined will show up there. But remember, if you've got Eastern region and Western region, they're both going to show up in this list. You got to make sure that you put the right feature template on the right device template. Okay, so once I have created this entire device template here, all the way from the top to the bottom, and the very first time you'll click on the save button. If you come back and edit it, it'll say update, but you click on save. What you've got to do now is you've got to attach that brand new device template now to a router. So you're under configuration and still templates. Now, when you'll see your list of templates here. The template you just created alphabetically is going to show up somewhere in this list, depending upon what the name of your device template happens to be. Go to the right-hand side here where you've got your ellipses, and this is where you'll find attached devices. So you click on attached devices. All of your routers that are currently not attached to any template will show up in this list. Now, hopefully you heard what I just said. Only the routers that are currently not attached to any templates will show up in this list. So if you're looking for a router and it's not there, first off, it may not be listed by its name. It might be listed by its chassis ID. So make sure you know how to identify your router. The names will show up on those routers that vManage knows about already that have been attached to templates in the past. But it may be indicated by its chassis number. In any case, find the router or routers and slide them from the left side to the right side. And then you click on attach. Now, once you attach, remember, we have quite a number of parameters defined in one or more of our feature templates that were device specific. So we need to now define those parameters. So when you click on attach, it's going to attach that device template using all of those features that you've defined using drop-down options, with exception of any parameter that is defined as device specific. That's what we need to define router by router by router. Now there's two different ways that you can get that information router specific into vManage. One, we'll call it option one here, is you'll see this window here, and this is going to be on a per router basis. So if you've attached a device template to 10 routers, then you'll do this 10 times. Chassis number is going to be shown there. You're going to define system IP, host name, system IP, site ID, IP addresses for one interface, IP addresses for another, and another, and another, and another. All the parameters need to be defined, and then you save it. And then you go to the next router and do the same thing. So there's a lot of typing involved here. Or you can download to your local computer a CSV file. And in that CSV file will be a list of all of your chassis numbers, All of this information you just need to populate. Type in your IP addresses, the names, etc., site IDs, etc., etc. And now, once you've got all of this information entered in for 1, 2, 3, 4, 8, 10, 75, 500 routers, then you can upload that back to vManage. And this is a lot more scalable of a way to go about it than to do this 500 times for 500 routers. So if you're only going to be changing parameters on 1 or 2 or 5 or 6 routers, you determine your tolerance level here. Then this might be the best way to go. But if you're going to be adding 500 routers or some larger number of routers, this by all means is going to be the more efficient way to go about it. Now this information right here, importing values and then uploading those values via CSV file format, let me show you where that's located. On this page right here, you've got a couple of icons at the upper right hand corner. We are on the list of our device templates. In the upper right hand corner, click on the download link. Sorry about that. Click on the download link and you can download that CSV file to your local computer and it'll look like this. Then all you've got to do is specify all the device specific parameters for those routers. Once you've finished, save it to your local computer, come back to vManage, and then you will upload that CSV file back to vManage, and now all of your device specific parameters will be added. Now if you're using option number 1 though, meaning I want to be able to implement the information on a per router by router basis, let me go back one page. After you click on attach to the device template, it's going to take you then to this page where you can then click the ellipses on the right hand side and say edit device template. When you click on edit the device template, you're going to specify each of those respective parameters for that one router and click on update. Then that will take you to this page where then you can click on next. Now whether you go through option 1 or option 2, you're going to end up eventually at the same screen in vManage, and I'll show you that in a couple of slides. So this is option number 2. Option 2 was you downloaded the CSV file, you saved it to your local computer, you edited the CSV file, you put in all the information that are device specific parameters for all of your routers, you save it, and then you upload it back to vManage again. So that would be option 2. So here's what that looks like. So here's all of your device chassis information, and so this is the information you've got to enter in on a per router basis. And once you've got all that implemented, then you merely click on upload and send it back to vManage once again. Okay, whether you choose to use option 1 or option 2, the next screen you're going to see is this page right here. So you highlight, now especially if you're doing more than a router. If you're doing say 4 routers, 5 routers, 6 routers, they're all going to be highlighted there on the left hand side. So here's the first router, and there's the second router, third, fourth, and fifth. You highlight the first router, and this is going to show you the configuration that's going to be pushed out to that router as a result of that device template. Now, where you're positioned here by default, when you click here, it's going to automatically show you the preview of the configuration. You cannot make changes on this page. This is a preview only. I encourage you, when you're looking at this preview, scrutinize every single character on every single line and make sure that everything that you see there is exactly as you would expect it to be. For example, your service provider organizational ID and your organizational name. Make sure that is exactly as you had thought you typed it in. Your IP addresses, your mask values, everything, just go from the top of that configuration all the way down. Once you've made the decision, okay, this is accurate. I don't see anything wrong with what I typed in there in all of my feature templates. Then you click on configure devices. Now this is the page you're going to see regardless whether you chose option 1 or option 2 for defining those device specific parameters. So now, it's going to take you to this page where we are in the process now of attaching that device template to the router. Now, by default, the only thing you're going to see on this page is this line here. So it doesn't give you any type of a progress indicator. So notice that there's a right arrow here normally, and that does not drop down. So you want to monitor the progress of attaching this device template to your routers. So drop the item down with a down arrow here, and then as the steps are performed, it'll give you an indication whether or not it was successful, and if it errored, it'll give you a little insight as to why it errored out. It's crucial to try to debug what you did correctly or incorrectly in your feature templates or your device template. What you're looking for, though, is the very last line. The very last line says the template was successfully attached to the device. Very important that you understand what happened if you see that message. If you see the message here that says the template is successfully attached, the template was successfully attached to the device, that means that you just migrated this router to vManage mode. You just changed this router from CLI mode to vManage mode. And you can prove it. Once you see that this is successfully attached to the router, open up an SSH connection to the router. Log into the router. You can still do that. Go into configuration mode. You can still do that. Type in commands. You can still do that. But then as soon as you try to commit, it's going to say, nope, not allowed. It's in vManage mode. And therefore, any modifications to this router's configuration can only be done in vManage. So when you attach a device template to a router, you change it from CLI mode to vManage mode. Okay. So the way that you change the router now from vManage mode back to CLI mode is either from the device list in vManage. Remember, you had an option there that says change mode. That puts it into CLI mode, or you can get to your templates. Let me go back a few pages and show you this. When you list your templates out, when you were in the process earlier of trying to attach the template, one of your options underneath that was also to detach. So on this page here, you went to attach the devices. Right underneath that is detach. So if you click on detach the device from the device template, you're automatically putting the router in CLI mode also. So that's two ways to, in essence, accomplish the same thing.
It happens if the device has lost communication with the management and control plane. Is there a way to manually on the device do that?
Nope. If you, and that's something that we can talk about if you need to as well. If you try to change the mode of a router from vManage mode to CLI or vice versa, and you get an error message in vManage saying that the network is unreachable, then the task that you just tried to perform failed. So until you establish reachability between vManage and that router is black hole. You can't do. It's going to stay in CLI mode until that occurs. Now, furthermore, and again, sometimes that's just kind of the things that we've kind of experienced in class already this week, where there was a network connectivity problem, right? The router went down, and you're trying to push a change, and the network connection is not there. So certainly, if I can't get to that device, or if any one of my controllers is down, I'm not going to push that change out until I can push that change to all my controllers, and then I'll go ahead and update that device. So, yeah.
So the reason I ask, reason I ask is, I mean, we've definitely, I won't say who or when, but we've definitely experienced an issue before with managed routers where someone has changed a configuration and locked themselves out of it, and so then manually you have to go into it on site to get the thing reconnected to get it programmed right. So I'm wondering what happens when you hit that oh shit moment.
Yeah, yeah, they need an oh crap button, don't they? Okay, so if you have truly black hole a router, um, and you can't get more of a black hole than this, and I'll describe it to you. So what happens if, and I think Jeff, you probably heard this as me communicating this to the tech support guys. If you've got a router and he thinks that he's in vManage mode, and vManage thinks that the router is in CLI mode, they're obviously in a disagreement with each other. So vManage thinks, okay, yeah, you can locally manage the router because he's in CLI mode. So you log into the router, try to make a change, and the router goes, nope, you can't do that because I'm being managed by vManage. So there's a disagreement between the two of those. They have to be in agreement in order for that to change. So because you can't make changes in the router because he thinks he's in vManage mode, then you're going to have to fix it in vManage. You're going to have to make sure that vManage knows that that device is also in vManage mode. So sometimes what happens is I really can't explain what's happening other than maybe a configuration script or something like that got corrupt, and the device can't change itself to CLI mode because of that corruption. So usually what I do is I create a CLI template. Again, we're talking about the difference between vManage or device templates created from feature templates as opposed to CLI based templates. And you can create a CLI template very easily. Just log into the router, do a show run, copy the full configuration, go into vManage and create a CLI based template. Paste that configuration file in there. It's a full config. It's exactly the same config that's running in the router right now, right? Give that CLI template a name. And now in vManage, detach, well, the vManage thinks that it's already in CLI mode. So in vManage, attach that router now to this new CLI based template. And as soon as you do that, he pushes, in essence, the same configuration it's already got to the router. The router thinks it's already in vManage mode, and now vManage thinks it's also in vManage mode. Then you can take them and vManage and put it in CLI mode, and they're both in agreement. So that's one way to get around a problem like that.
Gotcha. But if you've misconfigured all your interfaces to actually connect it to vManage, then you're basically left with a reset button.
Yeah, not necessarily, like you said before. That's that old crap button, right? So if you have isolated that router where you can't get to it anymore because somebody fingered the IP address, and somebody's going to have to log in locally to the router and make that change. So if you've got somebody on site that has the technical capability to plug in a console cable to their laptop and locally make the changes, assuming that it's in CLI mode.
Right, but if it's in vManage mode and you've got somebody physically on site with a serial cable, and there's no way of getting it back up without making a configuration change, you got to reset it.
Yep. Again, if you've got an isolated router and I call it black hole, which may be correct or not, but it's isolated. vManage can't get to it. It's in vManage mode. It's black hole. You can't do anything with it other than wiping it out.
High price, but I understand.
Now, again, the hope of that makes sense because you can see that there's the wrong IP address there, and it got pushed there because of a device template in vManage. Somebody made a mistake. That's why I was telling you guys before. When you're on this page, right? I already went too far back. When you're trying to attach the device template to the router, and you have the ability to preview the configuration, which is here, absolutely look at that. I mean, scrutinize it character by character, line by line. Because if you did that, you would see, oh, I got the wrong IP address in there. By all means, do not push this to the router because you'd black hole the router in a heartbeat, right? So scrutinize that before before you click on configure devices, if you see that there's a mistake in here, now if it's a mistake that changes the operation of the router, or it's something that's technically incorrect, when you try to attach it, it's going to fail. But if it's something like an IP address, vManage doesn't know what address should be there, right? So it's going to push it, and then you black hole the router. So make sure that you scrutinize everything on this output, character by character, line by line, before you click on configure. Otherwise,
Understood.
otherwise, your situation you just described will be staring you right in the face.
Hey Roger,
Yeah,
I seem to remember. I think there's like a back off timer that
the
kicks in.
rollback.
Yeah, isn't it like 5 minutes or something where it reverts to the previous config?
Yeah, there is a rollback that can be configured. So, and that anytime you're dealing with, you're at corporate headquarters, you're where vManage is located, and somebody's deploying a WAN edge router. That rollback is going to save you from having to go back to that remote location and make a change, especially if the router worked now and something in the new device template broke it. That rollback is going to be your saving grace. Okay, so all the features, the feature richness between V edges and C edges is certainly not consistent, right? So this kind of shows us on the right-hand side here that, hey, we've got V edges as shown here, and all of these are all of your models of your C edges. So here's the feature richness on the left-hand side. So what V edge routers do not support are switch port types of command. They don't support SVIs, your switch virtual interfaces, PPPoA or PVPoE, nor do they support multi-link, but all of the C edges do. So again, when you're creating templates, just make sure that when you create a feature template, don't associate, if you've got switch port types of commands, don't associate that both to a C edge router as well as a V edge router, because that V edge router simply does not support that feature. And if it is a C edge router, it is pretty similar to the pushing of templates to V edges. So you're still in your templates, list of your templates page in vManage. So you locate the template that you're going to be associating to a collection of C edge routers. You click on attach devices, and you'll go through the same series of steps we did before. You've got your Cisco configuration that's there. Just again, same thing, scrutinize that line. I mean, walk yourself through there line by line and make sure that things that could black hole you, like IP addresses, network masks, things like that, make sure that you fix that before you actually say configure device. And the same thing, this doesn't show the whole thing here, but it is something I wanted to point out here. So notice the very last line that should be there is that the template was pushed successfully to the device. It's probably there. You just have to scroll down on this bar to get to the last line. So sometimes there's more lines there than you can really see unless you scroll it down. So if you're pushing this configuration out to your WAN edge routers, again, it could be that vManage, your NCS server, rejects the configuration and the push fails immediately. So that's if there's something technically wrong with the configuration. If the configuration as it is accepted by the WAN edge router, it could still report an error and the push task is still going to fail. In other words, if it fails, what you're trying to do was not pushed out to the router. It is only going to be successful if you get the very last line that says template successfully attached to router X, Y, or Z. And if that happens, the configuration is committed to the iOS. You don't actually have to type in commit. It's just part of the process. And now you've got the successful push out to that router. A few things changed in version 18.3 and beyond. This one I don't really like, but it is what it is. So if you've got an interface on your router that is not currently being used in SD-WAN, this is what it does. It automatically does a no shutdown on that interface and puts a no IP address on that interface as well. So, most security best practices will tell you every interface on your router that's not being used, do a shutdown on it because that prevents somebody from plugging in a cable on purpose or inadvertently and providing you with a way of compromising the device. But this is what it is being used as since version 18.3. And your controller using cellular or T1 or E1 is not auto detected and has to be added by you. And if it's a TSN, VLAN 1 is the only interface that is indeed auto detected. Tracking commit using a transaction ID. Again, the template push in vManage still reports a success. So that's an error. Before it did not do that. So that's kind of a bad issue. And if there's a control flap with the push, vManage would try multiple times to reestablish connection, which is a good thing. And as of version 18.3, your 10 gig Ethernet interfaces are now supported, whereas prior they were not, as well as loopbacks. On your C edges, loopback has been available on your V edges for a long time. Always load replace when you're pushing a template. That way, again, that's kind of the rollback feature we were talking about before. vManage only pushes the difference. Right? So you've got a device template that is attached to a router right now, or you've attached a device template to a router, and then later on you went in and made modifications to that device template. And when you say, attach the router to that template, vManage only pushes the differences or the changes that were made to that template instead of the entire device template. We're going to talk more about logs later on in a subsequent module later on, but your logs are written to a file on the WAN edge router itself, and you may want to also look at your logs within vManage as well. Now, because the prompt is showing a $sign there, that means that we're inside a vManage shell. So the way that you get to this shell is you merely type in the vshell command. Now, this is not available on C edges. So this is not available on C edges. So you're not going to be able to go into the /var/log/nms and take a look at that log file. But I'm sorry. On vManage, you certainly can, but on C edge routers, this you cannot do. I put the error in the wrong place here. So not available on C edges. Here is that. So you cannot. This request platform software shell system shell command, that's not available on C edges, and certainly vshell is not available on C edge routers either. There is, I guess, a little information about that I can provide you with. Not anything that's really documented, but I was up in at a Cisco location up in Canada. I don't know, 4, 5, 6 weeks ago, and teaching this class up there. And the Cisco guys there were telling us they addressed the class and put in a small presentation for them and indicated that, yeah, there is inconsistencies between what you can do on V edges that's still not yet supported on C edge routers. And so, including commands, including things like this, that's not available on your C edges. And what I've been told is Cisco right now is in the process of fixing those inconsistencies between the C edge routers and V edges, as opposed to coming out with new releases down the road. Now, what we're told is the March timeframe is when Cisco is expecting that these bug fixes be resolved. So not a new version of software, but just bug fixes for these for all of the C edge routers. Because there's even inconsistencies between different models of C edges also. So that's what Cisco's working on right now, is getting getting SD-WAN consistency between V edges and C edges. You know, a good example. This is what's supposed to happen. Just to I don't want to go offline here too much, but if you wanted to take a look at your routing table on a V-edge router, you would just type in show. Oops. You just type in show IP route, right? Boom, done. Well, if you wanted to view a show IP route on the C-edge routers, what you're supposed to do is still type in the show command, but insert SD-WAN in front of IP route. And that's supposed to be the equivalent command on the SD-WAN side. Well, fact of the matter is, that command just simply does not work on any C-edge router unless it's been fixed recently. And that also holds true for all of the rest of those show commands as well. Show control connections, show SD-WAN control connections, show control local properties, show SD-WAN control local properties. So just insert the SD-WAN field in there in front of whatever it is that you're looking at on the V-edge router, and that is supposed to work in the C edges. If it doesn't work, then again, that's one of those parameters that Cisco's looking at resolving by the March timeframe. So I guess there's no need to dwell on that. That's just the way it is. You may get an access denied error. That's going to be kind of a permissions kind of a problem. So making sure that you open up your logs and see if you've got any rejected lines in there. Logging buffer is the default. You know, so 51,200 is your default. So again, this is for your log messages, and you can decide what level log messages you want to situate on your devices, and that's coming up in a later lecture as well. Again, no IP address and no shutdown is all part of your day zero implementation. And if it's an access denied error, as is referenced here, it's more of a permissions issue for your boot flash, vmanage, admin folders, or just make sure that the keys, they match between vmanage and the device. Okay, so that is SD-WAN templates. So I hope after going through a very short 29-page lecture that you have that I've elevated maybe your comfort level on what really is an SD-WAN template. You've got feature templates, device templates, and there's two different ways of configuring device templates, either device templates from feature templates, or you can create a device template as a CLI template, one or the other. And so now we start getting into SD-WAN policies. Well, you guys, it's 1:20. I really don't want to start. I've only got 10 minutes at most before we actually would officially break for lunch anyway. So why don't we just go ahead and break for lunch now? We'll come back after lunch. I'll go ahead and get started on the lecture to finish up the rest of the module for policies. And then the remainder of the day will be dedicated to labs 7, 8, and 9. And you guys that are still working in labs, go ahead and take lunch, obviously, but try to spend a little bit of time getting caught up in those labs. And I'm going to kill my video for right now, and I'm gonna also step away and go grab a bite to eat myself. I'll be back as soon as I can, and as soon as I'm back, I'll unmute my microphone and address any issues that we might have for the remainder of lunch. Here's your lunch timer. So we're all in agreement of what time to come back. So I'll see you guys back in an hour.